Chapter 11: Electric Current and its Effects. You will learn electric current, electric circuit and electric batteries, electric fuse and its characteristics, Orsted's experiment to show magnetic effect of current, electric bell and its working. You have learnt in class 6 how electric current is generated and how it is important to us. It is impossible to imagine the world without electricity. Electric current can be defined in simple terms as the flow of charge. In daily life, we use many devices which work on electricity. These devices help to make our life easy and convenient, but all these devices are useless without electric current. Electric circuit. The path in which electric current flows through a substance is called electric circuit. Suppose an electric cell is used as source of electricity. The electric current starts from the positive terminal of the cell, flowing through the conducting material and reaches the negative terminal of the cell. In other words, a continuous and closed conducting path connecting a cell and a bulb is called electric circuit. Open and closed electric circuits. Open electric circuit. An electric circuit through which no electric current will flow is known as open circuit. The electric circuit shown in figure A will be open circuit if the plug of the key is taken out or if the connecting wire breaks from any point. Closed circuit. An electric circuit through which electric current will flow continuously is known as closed circuit. Look at figure B. Elements of an electric circuit. All the electric circuits have some of the common and essential parts that are given below. 1. A source of electricity, cell, battery and house socket. 2. Conducting wires for making a conducting path for the current. 3. A switch to make the supply from the source on or off. 4. A device or bulb. Elements of the circuit, symbols, pictures. Battery or cell. A thin, long line represents the positive terminal and the thick, short line, the negative terminal for a cell. Combination of the same structure makes it a battery. Connecting wire. A thin, straight line represents the conductor. It is made up of copper and provided with plastic insulation. Electric bulb or lamp. Device working as a load and lights up when connected in circuit. Switch. It connects the circuit or disconnects the circuit. Real life connect. Aim. To make a lemon battery. Material required. Lemons, an LED or other low power electrical output. 2 galvanized or zinc nails for the negative terminal. 2 pieces of copper wire for the positive terminal. Connecting wires set up the circuit as shown in the figure. Potential difference. Imagine 2 beakers A and B of different size to be connected. If you fill water in one of them, it will flow into the other beaker too. But will the level of water be different? No. The water will flow from higher pressure to lower pressure till the level in both the beakers is same. If you need the water to flow continuously, this difference needs to be maintained and it can be done with the help of a water pump as you can see in the picture below. So, what is necessary for water to flow from one beaker to another? Can you guess? A difference in the level of water is needed if you want to establish a continuous flow of water. Similarly, in an electrical circuit, there needs to be a difference in the electrical charges at the 2 terminals of the source to ensure continuous electric current. In a cell, the positive terminal has higher potential and the negative terminal has lower potential. This establishes a difference in potential. Due to the difference in the potential in the 2 terminals, the current flows from positive terminal to negative terminal. When the circuit is the potential difference in an electrical circuit is commonly called voltage. It is measured in volts. The instrument used to measure potential difference of a circuit or voltage is called voltmeter. Electric batteries and their connections. When two or more cells are used to draw an electric current, the combination of cells is called a battery. Commercially, battery containers are used in the devices such as vehicles, clocks, and toys too. In a battery, the individual cells can be connected in two ways, series or parallel. Battery with cells in series. In this kind of connection, the cells are connected in such a way that the positive terminal of one cell is connected to the negative terminal of the other cell, leaving one free positive and one free negative from the cell, as shown in the figure. In this kind of connection, voltage increases but the current remains the same. It is used in automobile, flashlights, radios and toys, etc. Battery with cells in parallel. In this kind of connection, the cells are connected in such a way that the positive terminals of both the cells are connected to each other and the negative terminals of both the cells are connected to each other, making one positive and one negative terminal free for the connections as shown in the figure. It is used where there is a requirement of large current at low voltage. Fascinating fact, currently devices with rechargeable batteries are also available, such as smartphones, emergency lamps, etc. Effects of electric current. Electricity is tremendously useful, but it can prove to be extremely dangerous too if it is not harnessed correctly. Our effort should be to maximize the benefits while minimizing waste and risk. Electrical measuring instruments are based on the effects of electrical current. Electricity can be easily converted into heat and light, hence its usage is exceptional. Heating effects of electric current. When current flows through a conductor, some of the electric current gets converted to heat energy. This is called as the heating effect of electric current. If the conductor offers a huge resistance to the current, that means it opposes the flowing of the current. The heating effect produced will be more. Copper allows the current to pass extremely easily through it and offers very less resistance. Hence, it is ideal in making electrical wires, which are used for circuits. The heat produced also depends on the length of the wire and its thickness. In some appliances, the flow of the current makes the material so hot that it produces light. For example, in an electric bulb, the filament is made of tungsten. This material offers a lot of resistance to flow of current. Hence, it gets very hot and glows, and this produces light. When light is produced due to flowing of electric current, it is called the lighting effect of electric current. Thus, we can say that the electrical energy is converted into heat and light. For different appliances and requirements, different materials are used. In some appliances, electric current passes through a coiled wire inside it, called element. In case of appliances like electric iron, hot plate, geyser, electric kettle, hair dryer, etc., the element gets heated and emits heat energy. The amount of heat produced in a wire depends on material of the wire, thickness of the wire, strength of the electric current, length of the application of heating effects of electric current. The common household appliances which are based on the heating effect of electric current are 1. Common heater, 2. Hot plate, 3. Electric iron, 4. Electric toaster, 5. Immersion heater, 6. Electric geyser, 7. Electric oven. In these appliances, nichrome, that is a mixture of nickel and chromium, is used as an element. The nichrome wire of suitable thickness is wound in form of coil and then placed in some insulating material. The insulating material protects us from any electric shock when we use it. When the current is passed through the element, it produces heat energy. Electric bulb. In case of electric bulb, there is a filament of tungsten. The bulb is filled with a gas called argon. When current is passed, tungsten becomes extremely hot and produces heat and light as a result, since a large amount of electrical energy is converted into heat energy. Nowadays, CFL bulbs, that is compact fluorescent lamps, are used instead of bulbs which are 4 times more efficient than the filament-based bulbs. Electric fuse. Electric fuse is a safety device in an electric circuit. It is the weakest part in an electric circuit, which melts and breaks the electric circuit. It helps in protecting the device from getting damaged by breaking the circuit when there is a problem, such as very high current suddenly passing through the circuit. Sometimes the positive and negative wires in a circuit come in contact directly. It results in sudden heavy flow in the current, and this is called short circuit. Sometimes the wires can get overheated and catch fire, causing accidents. The circuit gets overloaded due to large current, due to short circuiting, due to fluctuations of current in the power system. It helps in preventing damage of appliances and devices. It also helps in prevention of fires caused due to electrical faults. Characteristics of a fuse. 1. Fuse is a short length of wire which has a low melting point. Generally, fuse wire is made from an alloy of 50% lead and 50% tin, which melts around 200 degrees Celsius. 2. Fuse wire has a high resistance. Thus, when the current flowing through fuse exceeds certain limit, it melts. Fascinating fact, nowadays instead of fuse, a device called miniature circuit breaker (MCB) is used. It has a switch which stops the current in the circuit if the current becomes more than a certain specific limit. An electric circuit through which more current passes than it can tolerate without heating is called overloaded circuit. Silver is the best material to be used as a fuse wire since it has very low melting point and melts in very less increase of current, but it is not used because of its high cost. Magnetic effect of electric current. The production of magnetic field around a conductor carrying electric current is called magnetic effect of electric current. Oersted, a scientist in 1820, showed that a wire or a conductor carrying electric current acts as a magnet. This effect is temporary, as the electric current carrying wire will demonstrate magnetic properties only as long as it carries current. Observe the pictures given below. When the current carrying wire is held above the magnetic needle parallel to it, the current flows from south to north and the magnetic needle shows deflection towards west. Similarly, when the conductor is held above the magnetic needle, current flows from north to south. The north pole of needle points towards east. However, if the conductor is held below the magnetic needle, the north pole of the magnetic needle points towards west. Oersted's experiment to show magnetic effect of current. Oersted, a scientist in 1820, showed that a wire or a conductor carrying electric current acts as a magnet. This effect is temporary as the electric current carrying wire will have to demonstrate magnetic properties only as long as it carries current. Oersted demonstrated the magnetic effect of electric current by bringing a magnetic compass needle near a closed circuit. He found that when a circuit consisting of copper wire, switch and cell was held above the magnetic needle parallel to it, the magnetic needle deflected. When the magnitude of the current was increased, the deflection of the needle increased too. Procedure. Remove cardboard shells from discarded matchboxes. Wrap the electrical cord several times over the cardboard tray. Insert a small compass needle. Then connect the free end of this wire to the battery through a switch. Then set the switch to the on position. You can see that the compass needle swings when current flows through a nearby wire. Therefore, when a current flows through a wire, it behaves like a magnet. This is the magnetic effect of electric current. Magnetic properties of a conductor carrying current, electromagnetism. When a coil of insulated wire is wound on a magnetic material like iron and the current is passed, the magnetic material acts as a magnet. The magnetic material around which the coil is wound up is called the core. However, it behaves as a magnet only as long as the current passes through it. Such a temporary magnet formed by passing of a current through a magnetic substance is called electromagnet. The branch of physics which deals with the relationship between electricity and magnetism is called electromagnetism. Practical uses of electromagnets. 1. They are used in electrical appliances such as electric bell, electric fan and electric motors, etc. 2. They are used in electric generators where very strong magnetic field is required. 3. They are used in television. 4. They are used in magnetic separation of iron ores from the other substances. 5. Strong electromagnets are used in cranes and factories to lift heavy iron pieces. 6. They are used by doctors to cure certain diseases. Fascinating fact. One of the interesting uses of the electromagnet is in the speakers of music system. An electromagnet is formed by making a coil of copper wire on a round iron rod and supplying power to this produces a high noise which is given out from the speakers. Electromagnets are extensively used in the motors and generators. Electric bell. Electric bell is a direct application of the electromagnets. It consists of the electromagnet, armature, contact spring and hammer and gong. These parts are fitted on flat wooden or plastic board. Electromagnet. A soft iron rod is bent in U-shape and on each of its arms a coil of insulated copper wire is wound with a large number of turns. One end of the insulated copper wire is connected to terminal and the other end to the brass stud of the armature. Armature. It is a soft iron bar suspended with the help of a flat spring such that it faces the poles of the electromagnet. Contact spring. It is a flat steel spring slightly bent and fixed to the armature with the help of screws. At the other end of the spring is attached a hammer and gong. The hammer is made of steel and is attached to the armature. The gong is made of brass. When the bell operates, the hammer repeatedly strikes against the gong, thereby producing working of electric bell. When the switch is pressed, current flows through the electromagnet. It then attracts the iron bar or the armature towards itself. This movement causes the hammer to strike the gong. Instantly, the armature loses contact with the screw, the terminal to which one end of electromagnet is fixed, and the circuit is broken. The electromagnet loses its magnetism and the armature comes back to its original position. However, as the armature returns to the original position, the electrical contact is re-established. The armature is again attracted towards the electromagnet. In this way, a rapid cycle of make and break of the electric circuit takes place and the hammer hits against the gong, producing a ringing sound. Fascinating fact. Nowadays, the electric bells are replaced by electronic bells in which different sounds are being inserted in the circuit through the electronic musical circuits instead of the hammer and gong. When switch is pressed, instead of hammer and gong, the electronic music rings. Subject integration. In our daily life, various domestic equipment and devices require electricity range from simple to complex. These range from basic domestic equipment such as a coffee maker, dishwasher and microwave to large electrical appliances such as air conditioning units, refrigerators, electric heaters, dishwashers and dryers and so on. Skills and values. Electrical safety is a general practice of handling and maintaining electrically powered equipment to prevent incidents. Everyone should follow safety rules like prevent electrical equipment from contacting wet areas, ensure safe use when unplugging, install properly and tidy electrical cords, etc. Batteries should not be thrown away as they contain harmful chemicals. Rapid review. 1. Electric current has electric energy. 2. The path along which the electric current flows is known as electric circuit. 3. The metal cap of an electric cell is its positive terminal. 4. The base of an electric cell is its negative terminal. 5. An electric bulb is a device which changes electric energy into light energy. 6. An electric bulb has two terminals. 7. The complete path from one terminal of an electric cell through the bulb and back to the other terminal of the electric cell is called electric circuit. 8. A complete circuit is called closed circuit and the current flows through it. 9. An incomplete circuit is called open circuit. It is broken at some point and no electric current flows through it. 10. The switch is a simple device which easily closes or opens an electric circuit. 11. The electric current gets converted into heat energy. 12. In some appliances, electric current passes through element. 13. Electric iron, hot plate, geyser and hair dryer, etc. are the elements that get heated and emit heat energy. 14. The amount of heat produced in a wire depends on material of wire, thickness of wire and strength of the current. 15. Electric fuse is a safety device in a circuit. 16. Oersted showed the magnetic effect of the electric current by an experiment. 17. Electric bell works on the effect of electromagnets in the electric circuit. Key points. Electric current, the flow of electric charge in the form of electrons in a substance from one end to the other end of the substance is known as the electric current. Electric circuit, the path along which the electric current flows is known as electric circuit. Open electric circuit, the path of electric current that starts from the positive terminal of a cell and is broken at some point and doesn't complete the path is known as open electric circuit. Closed electric circuit, the path of electric current that starts from the positive terminal of a cell and ends at the negative terminal of the battery is known as closed electric circuit. Fuse. A fuse is the weakest part in an electric circuit which melts and breaks the electric circuit when the circuit gets overloaded and prevents damaging of appliances as well as electrical fires. Electromagnetism, the property of a magnetic substance to acquire magnetism temporarily when electric current is made to flow through it, is called electromagnetism.